Awesome. Just kind of quick show of hands. How many of you have ever needed the root user to do something urgent in your AWS account? All right, a few of you, all right. You can keep them up if you ever enjoyed the process of two people being on call, someone digging an MFA token out of a safe, doing a change window at 2 a.m. because you cannot touch your production environment during the day, all that sort of stuff. Yeah. Difficult problem a lot of people experience all the time. So yeah, imagine you're not doing that only once a year. You're doing that probably a few times a quarter, maybe hundreds of times across hundreds of accounts, more than you could fit on a single screen. So yeah, today we're going to tell you a story about how can you make all that go away. All right, so in this talk, we're going to talk about one of the very first identities, which is the AWS root user, and why it could become actually a real headache when you run a lot of accounts and adding on top of that a new AWS capability called centralized root access that changes really the game here. So I'll cover the background, the mechanics, and then James will share what his team how they put this feature to work in their highly regulated bank. So just kind of why we talk about why root credentials, how centralized root access could help with this, and then we're going to hear the bits about JPMC and how they went from discovery to automating the whole process, and we'll finish with a handful of best practices. So I'll just going to start with a little bit of a timeline. So cast your mind to 2006, where AWS had a single root user, and that was the only way in. There was a single account model, single root user to get into your account, and it was pretty simple, if risky, because that single user had access to everything. It could do everything. Fast forward to 2011, we've introduced AWS Identity and Access Management, IAM. And when IAM arrives, now you could create users, you could create roles, attach policies, and follow least privilege. And then now root gets pushed out to being a break glass only model or a user. Jump to 2017, customers are running now hundreds of accounts, running in isolation for different purposes, billing, blast radius. And that's where AWS Organization launches to help with that. Giving us the management account structure with various organizational units and member accounts under that organization unit, and also controls like service control policies to govern your accounts. Then the problem here is still that every time you spin up a member account, it still came with a root user. And that root user just kind of, as the more you create, the more the problem keeps growing. Now that brings us to November 2024. Where last year we introduced centralized root access. From that day forward, any new member account that gets created within your AWS organization comes without a root password, no access keys, and you have the ability to do the same for existing accounts where you could delete these credentials at the moment you enable the feature. So this changes kind of the game from root being a long-standing, long-term credential to a short-term credential with an on-demand capability offered through this feature. And that's essentially kind of the quick backdrop of what we're going to cover today. So first, for anybody that's not familiar with AWS organizations, here's just kind of a quick primer. At the top, you've got a management account. Think of it as if it's your mission control. Under that, you create member accounts and group them in different organizational units and map them to the various teams and environments. And then all spend kind of rolls into consolidated billing, so finance could see a single invoice. And then you could apply security using service control policies that could deny or allow specific AWS APIs and help you do that before even IAM evaluates permissions. And then from there, you could organize things, run shared services, logging, networking, CI/CD in their own accounts, and do administration that way. So keep that structure in mind, as it's kind of important for how we're going to talk about centralized root access and how it directly maps to that. So here's a view of an AWS organization. We're going to put some credentials on that diagram. So you've got your one management account. you might have several OUs. We're just going to put one here. And inside that OU, you've got dozens of member accounts. Every one of those member accounts still carries a root password, a root credential, and possibly protected with MFA as a best practice. Probably you have policies or procedures to rotate that on schedule. But the problem here that each rotation could mean a change ticket or a middle of the night change window. And again, like this is just kind of a simplified view of an AWS organization. Probably for a larger institution, you could have that across hundreds of accounts, and that could get a really a big operational burden on you. So when I say operational burden, how heavy is that? So for example, like a lot of our large customers could take, told us they could take from several minutes of human intervention every time they want to touch root. For example, procedures include unlocking a safe or logging in through a system, rotating that password, updating the vault, keeping records of that, closing the ticket. And then that gets kind of multiplied as you look over multiple or hundreds of accounts. And that works out to kind of weeks every time or every quarter, or engineering effort that's possibly wasted on non-strategic work. And then the problem that adds to this is also when audit season arrives, you've got auditors asking two simple questions that's sometimes hard to answer, which is, could root be used? And if it could be used, how is it protected? Then you've got your operational teams kind of scrambling to, go through vault exports, change records, CloudTrail logs, just to prove that nothing happened, or at least like it was all safe. Also, we've had service control policies. So root was not really left unprotected. So long before this feature that we're going to talk about, we had many customers use service control policies. Service control policies are a type of organization policy that help you manage permissions in your AWS organization. For example, like this service control policy presented here, it denies every EC2 API call when the principal is root. I think it works, but you cannot touch, root cannot touch EC2, but it's very blunt. And if you genuinely need root for an emergency access, first you would probably have to move your AWS account or that specific account from your AWS organization, or relax that policy to do your the job that you need to do. And remember to undo all that once it's done. So effectively, yes, it's protected, but it feels a little bit manual and then some operational tax there. So root still exists for rare actions. For example, recovering a locked S3 bucket, you need that for root. SQS queues, or enabling IAM access for billing, for example. But those events are rare and far in between. Yet every account carries a password and an MFA that still needs to be protected. So again, root is powerful. There's no argument there. But managing hundreds of these root passwords, MFA tokens, and storing them and protecting them is not strategic work. Also, it feels like manual work at times. And our goal here with launching this feature was zero standing credentials and transition that to more like short-lived, fully logged credentials and only used for rare exceptions. So what we built, so to address this problem and reduce the operational burden, we launched centralized root access in November 2024. You turn on centralized root access in the management account or delegated admin account at one time for that organization. And once enabled, the first thing that you get is basically an inventory to see what's the state of the root credentials in your AWS organization. Which account has a root password, has MFA attached, or doesn't have MFA attached? Is there any signing certificates or access keys attached to these root users, and so on. And then second, you could choose to delete these credentials altogether. And then all these actions, of course, like once you delete these credentials, get captured in CloudTrail, so you've got all the traceability and audit that you need for any audit requirements that you need to satisfy. And then when new member accounts get created in your AWS organization, as I mentioned earlier in the talk, is they would not have any root credentials altogether. They will come without any root credentials, so no passwords, no access keys. And then third, when you essentially when you have any need for performing any sensitive actions, for example, like you have an S3 bucket or an SQ policy that you need to perform, you would use your management account or delegated administrator account and request a short-term lived session that's tied to a single member account that expires by default within 15 minutes, and that gets fully logged all the way through. And then all that is also available in the console through APIs and through automation. So you could basically integrate that with your ticketing system and you automate all things related to kind of the discovery of these credentials, whether you want to audit their state, the cleanup, which is removal of that, or even adding, requesting any of these short-term sessions. The benefit you get of all of this as well, like your security teams get this auditability feature as well, so they could monitor the state of these credentials and tools, like whether it's in the IAM console, things like Trusted Advisor as well, where you could get reporting on that. So here's a quick checklist that we recommend. First, delete any standing root passwords or access keys in your member accounts. Second, keep them from coming back by leaving kind of guardrails on, for example, these SCPs that block long-lived root credentials or their usage. Third, when you truly need root, only do it from the management account using a short-lived session. And again, like access to your management account ideally would be protected by MFA, and that could be fully logged as well. And then fourth, keep an eye on that posture, right? Like you've got Trusted Advisor will show you greens when you're clear, and CloudTrail records for any of these kind of actions that you take. And finally, continue to protect your management account with root and reserve it only strictly for any break glass scenarios. And that sets the stage. So James now will show how JPMorganChase kind of centralized their root access across their multiple AWS organizations and reduce the huge amount of work. So sure. James, off to you.
Thank you, Khaled. So just a quick recap of JPMorganChase's journey into cloud. So we've had the honor of presenting at Inforce before, and then our CIO, Lori Beer, presented about our cloud journey at reInvent last year. As covered in both presentations, AWS footprint for JP Morgan is thousands of accounts running trillions of payments annually, right? We're constantly partnering with solutions from AWS and other cloud providers to try to innovate on security in the cloud and make it best practice for our organizations and the financial industry as a whole. So, as Khaled said, root accounts are secure. We don't want to say that centralized root management was necessary to make it secure. It's just an improvement upon what was already there. You still have a 64-character randomly generated password, and as you heard in the keynote, it's now enforcing MFA across all of accounts. But if you're in a large organization such as ourselves, it becomes very difficult to manage that, right? It requires multiple people, multiple man hours to improve the security over it or improve the manageability of the security. And this process allowed us to simplify that greatly. As I said, it's generally best practice in an industry as you vault your credentials in a enterprise-grade vault with an enterprise-grade MFA that usually you have a separation of duties that is a different organization from the individuals who manage your cloud. And it requires a rigorous process to keep it up to date. Typically, you want to make sure that for high security workloads, you want this MFA and you want this root credential maybe vaulted ahead of time just in case you need it in an emergency, which takes multiple man hours. So what centralized root management does is it allows you to use IAM, right? So I would encourage all of you get a benefit immediately by turning this on, where you don't make the problem space any bigger for yourself, but you haven't introduced any risk either because you can always go and generate the root credential should you need it. But as we'll go through in the presentation, for the most common use cases, you may not actually need the root credential, right? This allows you to increase the time to market for providing new AWS accounts for your sensitive workloads because you no longer have to worry about vaulting that root credential. Also, it adds security in that it does remove the login profile, so even if an attacker figures out your email address, they have no opportunity to ask for the password to be reset once the login profile is not there. And I do want to encourage that this allows all your existing processes that you may have built in your organization to continue to function should you have a root credential. So it's a warm standby or warm cutover process. It's not like you have to change how you do root today just to get the benefits of this service. So the most common actions are wizards now. As Khaled talked about, the most common things that typically people see in development accounts is that a developer writes a bad S3 policy, locks themselves out of the bucket. Well, now the benefit of centralized root account management is not only do you have a wizard through the console, but even if you do it through the CLI, you get not only a short-lived token, which is, whereas root you might have a longer session, that token is specifically scoped to specific API actions where that individual performing that action can only list the buckets, get the current bucket policy, and update the bucket policy. It allows use of federated just-in-time roles or whatever your preferred method for privileged access is to the cloud, which the key point there is unlike the root user where you may have to go to your enterprise vaults to find out who checked out the password. You can trace it back to employees who actually use the root credential in centralized root management to figure out who actually did the cleanup of that S3 bucket. It also allows you to do this safely without that long-lived credential. So it's a big benefit to know that AWS is managing it, so it's only 15 minutes for you to do your job, and honestly, the operations that you need to do, that's more than enough time to do what you need to do. The big advantage of this as well is you can start to automate things. So taking the S3 or the SQS example, if that's something that commonly happens in your development environments, you can switch from having a human being manage it to providing, say, SSM automation documents that can assume root from the centralized account or the delegate account to allow application teams to unlock their own bucket or their own SQS with a default policy. So you can federate that out larger. It also means you can safely federate supporting root operations to larger organizations, right? Typically due to the pain of what the root user can do, organizations tend to keep root to single sets of individuals or single groups. This allows more federation of solving those problems, so we can federate the responsibility without increasing the risk. I did want to go through, there are additional ways you can protect root that they've added onto with AWS. So the nice thing is, Khaled spoke about the SCPs and the RCPs. It is possible for you to build an SCP where you disable the root user, but still allow centralized root access management to work. So this is an example from an AWS blog where you see that they're using the new condition key, AWS assumed root equals true. In this case, it's setting it to null to say that I'm going to block all actions from a root user unless it's assumed root credential. So that way you can, if you want to, and you don't need root for other solutions that are not there yet, such as older billing statuses, you can fully buy in to the centralized root management process without causing any additional risk for yourselves. So I did want to summarize benefits for this. Like I can say, for JPMorgan personally, we spent hundreds of man-hours over the lifespan of AWS to manage and vault these root accounts, and we've been able to help reduce that time significantly so that those individuals can spend more time improving our status on the cloud in other areas than doing simple password management within the organization. The ability to scope and reduce these root credentials are really powerful. Khaled talked about audit. It's very easy to now have a conversation with your auditor to say, how are you protecting root for this particular account? Well, I don't need to because it no longer exists. Right, root is just not there, and I use the central wizard. And then also, it helps with also managing cost allocations on your enterprise vaults, right? You have a lot less credentials you need to vault and maintain. And there's a true life cycle that you can do with the root user should you need to build it, where you can truly get just in time with even the root user itself. You build the user, give it a password, give it an MFA, go in, do what you need to do, And then using centralized root account management, you can quickly delete that user and lose the risk associated with that root account. The email address stays, so you don't have to worry about coming up with a new email address every time, but the credentials disappear so that you don't have to worry about keeping them vaulted or keeping the MFA on. I'd like to thank you all for your time. If there are questions, we can take them over on the side, but thanks again. And as I said, if there's one thing I can say from our experience, right, this was one of the least risky and simplest solutions for us to turn on, and it improved our security status greatly. And I encourage all companies to do it simply because it improves the overall health of the AWS ecosystem.
Awesome.